Hi, this is Mastering SELinux, SELinux Administration Session 8, working with SE Module and Object Classes. And I always say, and you have already pointed out, Rahman, that whenever you have any question and the question before we proceed, I get my answer of my question. You ask me how many classes are there, where we can find the classes, and this is what I told you, that you will be getting the answer very shortly. And here in this session, you will get the answer of that, where all the classes are located. Can we have the list of all classes? Can we modify them? Answer is yes, and you will see that list of classes here in this session. Okay, agenda of the session is high level SELinux architecture. This is blow your mind actually, because you will see how SELinux works overall, the complete architecture of overall a high level architecture. SE module, object classes and permissions, defining common permissions and examples. And the highlight of the session is the architecture, and this is it, high level architecture of SELinux. So this is a high level architecture of SELinux. When we understand, and SELinux aware application, it starts from here. The application which is aware of SELinux, they have a user space object managers where we have access vector cache, AVC. These can be library libSELinux AVC services as need, or use their own as depending on the SE GraphSQL. Then here what we have is the policy. This is the policy store. So when we have the policy store, in the policy, this is located into the etc SELinux policy name modules, and this is what we were building. We were building this SELinux policy name. In our case, it is a policy, the Skillpedia and the SE module, and then under that we have the policies, and policies are locked. Then we have AVC active policy name. You can get the active policy name by using SE status. The active policy, current policy is like 31 right now, and the configuration file for SELinux configuration file, config file, or scmanage.conf, and then this other policy configuration files are there here. So loaded policy will reside into the file system Linux kernel services. This is Linux kernel service, SELinux kernel services. So when the access vector cache and security server, and this is what demonstrated in the previous lecture. I think one of the previous lecture, where we talked about the kernel space. In the kernel space, your access vector cache and security server is loaded, the policy is loaded into this SELinux. So whenever any request comes, SELinux supports a security policy, X attribute process APIs. So API calls were made to the security server, to the SELinux server, and check whether it is available or not, whether it is a hit or it is a miss. Then it is responded with that hit or miss based on the kernel service. This is the kernel headers, reference policy kernel headers, or reference policy source, or custom policy source. Then we have audit logs, labeled file system, and network USB connectivity, etc. So here, when we have a policy right from source, if we talk about, we have policy headers, reference policy source. We use check module to compile the policy. It starts from here. So check policy, compile the policy source into the intermediate format, which will generate policy object file. Then we use SC module package, which will package the policy, that is PP. So PP file is created, package file is created with the optional configuration file. So optional configuration file is supported along with that. So object file from the source, optional configuration file which is created by us, so sent to this, and it will generate two things, policy file and the SE module. It manages the policy store by installing, loading, updating, and removing the modules and their surrounding configuration, supporting configurations files. Also build the binary policy file and the corresponding policy file. Here, so this is what is generated as the policy after the compilation. So from here to here, this is the policy file generation, which we have done in the session just now. That is compiling the policy source, developing our own policy from the source code. Then once it is done, we have SE manage to configure the policy store. We did it and we have been doing it and will be continue working with SE manage. Configuration elements of the policy such as login, users and ports in this. This is libSE policy, library SE policy, right? These libraries are linked into the SELinux aware applications as required using the API calls. And here policy core utils which gives you a lot of utilities like SELinux utilities such as SECon, audit to allow, SEconfig SELinux. Then file labeling utilities are there to allow you to configure the SELinux policy or change the behavior or role or rules of the game. The utilities are there supported, given to you for managing this. Then file labeling utilities that initiate or update file security context such as set files and restore contexts. Same way we have Linux commands, SELinux commands modify to support SELinux such as ls or ps or pam. We have Linux commands which works. So together these interact with the SELinux policy, and the SELinux aware application make calls through API to the kernel where the SELinux module is loaded. So this makes the complete SELinux architecture. This green area background, green background is SELinux user space services, where your services are running, where you are allowed to work. So if you look at what is outside your scope, where you are not working, you are not interacting with the kernel, you are not working with the source, you are not working with the source, the policy itself. You are using utilities and commands to configure the behavior of the policy. So with the green color is your space, user space, and this is your SELinux aware application which you are trying to control through the command, through the utilities, through the policy by changing the setting the environment. This is overall SELinux architecture, a high level architecture of SELinux, and I'm sure this have cleared a lot of doubts and has given a lot of clarity in terms of how SELinux actually work. The one picturization, can we have one shot picture of SELinux? Yes, this is it. So now it is taking a time to load the next slide. So let me just navigate through the slide so that it generate the thumbnails, and then it will not take much time to move on to the next slide. So let me do this process once and for all so that it generate all the thumbnails in one go and load them into the cache. Next time it will not be taking much time to load the next slide. So let me just walk through all the slides once. That will save my time in continuity. Because otherwise it's a lot of time gap, few seconds of gap every between every slide irritates, and it annoyed me. So sometime system goes slow, I don't know why, but then we have to understand it. No problem. I just go through the slides, all the slides once, and then after that it will not take much time. Okay, now it will not take much time. SE module. The SE module is the tool used to manage SELinux policy module, including installing, upgrading, listing, and removing modules. The previous session we discussed quickly, the syntax of the TE file, the rules of the TE file, the classes, the attributes, how we specify, how we develop a policy. So how to develop a policy module, how to write a policy module. SC module is the tool which is used to manage these modules, including installing, upgrading, listing, and removing the modules. So after the rule is created, after the three files are created, what next? Next is SE module. SE module may also be used to force a rebuild of policy from module store, or to force the reload the policy without performing any other transaction. SE module act on module package created by SE module package. Conventionally, these files have to have a .pp suffix, that is policy package, although this is not mandated in any way. SE module options: -r or -hyphen reload force a reload of the policy. -b or -hyphen build force the rebuild of a policy. Also reload unless -n is used. -i install module package name, that is pp file. You can use -i to insert that. -r to remove. -l is kind of a link module, display list of installed modules. Sorry, -l, it is not -l is listing the modules. -l, then -e extract a module from a store in the current directory. The name of the module written is module name dot language stack extension. For example, we can have standard or full list of modules, or standard list of modules. SE module in action. What we should do? SE module -b base pp. Let's take a look at first whether our installation is complete or not. Thanks, Eman, for your feedback. Let me see that also. Yeah, system has come back, Rahman, and we are good to go. That was the only error. We just missed that make install source. After that, we used all the steps as discussed, and there was nothing wrong, and system come back properly. Now we can use SE status command to verify our system that yes, it has installed the latest policy built from the source. And we were right. I was right when I specified that it is probably because I missed one step, that is the default source file location has to be in the default location only. So install source is mandatory command. So if you miss that, you will be into problem. So remember, this is a good learning for us, and that's how we learn. If we don't commit mistake, we will not learn. I'm happy that I committed that mistake. SC status. Wow, my policy is loaded. Policy name Skillpedia. So here I am. That's fantastic. So my policy is the Skillpedia. Policy version is 31. So I'm using my own policy now. Bingo. Now let's look at this base.pp. I don't have any file, so I cannot install it. This is example. So let's take it as if we have a policy base.pp. So SC module -b, that is build base.pp. So to use this command, I'm sure you know by now that there must be three files. One is base.te, which is mandatory, and base.interface, that is if, and base. One more file was there. The three files are mandatory in order to use this command, that is build base.pp. So base.te, tt, base.if, and base. One more I always forget. No problem, my age. Install or replace the non-base policy package -i, and this is the once the policy package is created. For non-base modules, you can use SC module -l. Turn on AVC messages for which SELinux currently is not on it. For example, you can use SC module -db. So SC module is a command to manage your modules once you have developed, once you have written them. Turn down audit rules back on. SC module -b. Install or replace a non-base module in the current directory. SC module -i star.pp. Install or replace all modules in the current directory. ls star.pp, grep ev, base.pp, enable audit.pp, whatever it is. And then we specify x args, and then SC module command -b base.pp -i. Disable a module. SC module -d, module name. So we can insert, we can replace, we can build, we can install, we can delete. These are SE module commands. List all modules, SE module hyphen hyphen list is equal to full, or hyphen hyphen list is equal to standard. Set the alternate path for the policy root, SE module hyphen b hyphen p slash temp. Set an alternative path for SE policy store. You can use the policy store path to different SE Linux. Like for example, SE module hyphen b hyphen s temp var lib SE Linux. Write a high level policy version of Puppet and a CIL version of Wireshark module at priority 400 to the current working directory. These are all again examples of policy with different priority and different values. So hyphen x 400 priority is 400, HLL Puppet hyphen a is CIL, we are specifying CIL, and Wireshark. So this is some examples are necessary to understand the overall concept, and these are some of the examples where we discussed SE module, how it is to be used. Now your question, object classes and permissions. Within SE Linux, an object is a resource such as files, sockets, network interface that are accessed via processes, also known as subjects. These objects are classified according to the resource they provide, with access permissions relevant to their purpose. For example, read or receive or write, or whatever they want to do, and assigned a security context. This is I think a very clear understanding by now. Each object consists of a class identifier which defines its purpose, like a file or a socket, along with a set of permissions that describe what services the object can handle, read, write, or send, whatever. When an object is instantiated, it will be allocated a name, like a file could be called as config, or a socket may be my connection, and a security context like system user, object role, and SE Linux context. So this is what is done when it is instantiated of the class. So what is the class look like? What is that is the class? Object class. Object class, for example, object class file and permissions. The policy rules would define those permissions allowed for each process that need access to this config file. This is one example. This is not a typical, this is just one example that this is the file, how it is written. So in this case, in this particular file, if we look at only this particular file as an example, we are taking example here. We are not talking about the configuration file, quote unquote configuration file. We are not talking about that. We are talking about one example file. The file name is config, which is under SE Linux. Now, object of the file object class, because this is a file, config is a file, so it is a file object class. So, and the file name is config, and the context is system user object are SE Linux config. So this is the object of type file, of class file. The file name is this, security context is this, and then it has some associated permissions like read permission, write permissions, append, etc. These are the permissions on this object of class file. Alright, so class is file here, and the object of the class file, example object is file, this config, this is the object, this is our object, right? So now it is very clear that object of file object class, and in our case this is the object config, and this is the security context for this object, right? So this is how we say object class. This is how we define object class. Object classes and permission. The objective of policy is to enable the user of the object or the subject access to the minimum permissions needed to complete the task. These object classes and their associated permissions are built into the kernel and user space object managers by developers and are therefore not generally updated by policy writers. The object classes consist of kernel object classes for handling file socket plus user space object classes for services such as X Windows and dbus. The number of object classes and their permissions can vary depending on the features configured in the SELinux release. A comprehensive list of these object classes is listed as SELinuxproject.org page object classes this permissions. So let's take a look at this URL, and this is where we have all the object classes. SELinux project page object classes. This is the URL, and here you get all the classes, the list of classes, and these are categories of classes. And here we go. Yoo-hoo! Yoo-hoo! The files and that all the classes with their permissions applicable. Over to you. You can investigate whatever you want. So let's talk about the file which we are working on. Alright, let's see that file object class dir and the file. Here we have file. So what are the permissions on the file class? Look at this. These are the permissions and the description of the permissions. Get attribute, relabel, unlink, IOCTL, execute, append, read, set attribute, swap on, write, lock, read. These are all permissions on the file class. So any object of type file can have these permissions associated with it. This is what we were talking about, and this is what you asked probably. Oh, I did not share the screen. One second, I did not share the screen, so let me share the screen, because you could not see that. I just opened that. Sorry, now you can see that. This is the URL opened. I hope you can see the screen now, and this is the URL which I was referring to. I was excited when I opened this URL. So this is the page SELinux project page object class permissions. So here you see all the objects and their classes. So SELinux object classes and permission reference. So you can find out the comprehensive list of any type of object here, any class here, and the corresponding permissions here. And this is what I was talking about is when I was saying that file. This is the file class, and the permissions of on this object of type file will have this get attribute, relabel to, unlink, IOCTL, execute, append, read, set attribute, and all this. So this is list of all objects, all classes, their corresponding object, and the permission associated. So this is what it is. Now let's continue. So URL is given in the slide. So here you can get the list of all of them. For those who write or manage SELinux policy, there is no need to define new objects. There are associated permissions, as these would be done by those who actually design or write object managers. So you don't have to, you simply use that, because for example you don't have to create your own permissions for, or file type object. When you instantiate any object of type file, you don't have to write your own permissions. Object classes. A list of object classes can be found in the reference policy source also, which you have done, which we have downloaded from where we have built. So we can see this list here also. Under the policy, under the source code, you see policy flask security classes file. Object classes are defined within the policy as follows. As I said, class ID, where class is the class keyword and class ID is the class identifier. And the valid statement in this particular case are monolithic policy, it is applicable, yes. Base policy, yes. Module policy, it is not applicable because we are talking about one particular class. Conditional policy, if statement, whether this is allowed or not. So what is allowed, what is not allowed, this can be this statement can be valid in or not valid in these examples. So these are validation criteria for this. Same way, object class example, simplest possible example, to define PostgreSQL db tuple object class, you can use simple class db tuple. That's it. That's how you define it. Permissions. A list of permissions used by reference policy are listed into policy flask access vectors. Permissions can be defined within policy in two ways. 1. Define class specific permissions. 2. Define a set of common permissions that can then be inherited by one or more object classes. The permission or access vector statement definition is class, class ID, inherit common sets, and the parameter sets. There must be at least one common set or one permission set defined within the statement. So class is the class keyword, class ID the previously declared class identifier. Inherit means optional inherit keyword that allows a set of commonly permissions to be inherited from the superclass. Common set, previously declared common identifier, and permission set is one or more optional permission identifier in a space separated by enclosed braces. So this is how you specify the permissions. Examples. The following examples show db tuple object class being allocated two permissions. Class db tuple relabel from relabel to. So these are two permissions allocated to this. Same way, db blob object class inheriting permissions from database set of common permissions. Class db blob inherits database. Same way, db blob object class inheriting permissions from database set of common permissions and adding further 4 permissions. Class db blob inherit database, add read write import export addition in addition to what were there. So this is how you can define classes. This is how you can define permissions on the classes. You can inherit them from the given list or you can add your own. Defining common permissions. New or updated common permissions would only be updated by those who produce kernel or user space object managers. And the statement definition is common ID, permission set. This statement is valid in monolithic policy, base policy, module policy is not applicable. Conditional policy, yes, if you use if statement, and base policy optional statement is not applicable. It is not applicable. Conditional policy, it is not applicable here. So required statement is not applicable. What kind of statement you are giving, whether you can give this permission using this statement or not, this is the example of that, validity of that. Define common PostgreSQL permissions. Common database, create, drop, get attribute, set attribute, relabel from, relabel to. So this is one example of common permissions. So this is how you can set the permissions. And that's all for this session. Thank you very much for watching. Bye bye.